let's take a look at today's lesson. What we're going to be doing on today's lesson is we're going to be looking at applications. We're going to take the things that we've been practicing, writing equations from graphs and using our calculator to actually work application problems. So these kinds of problems are kinds where they typically describe like a sinusoidal, like a water wheel, for example. We know water wheel, it would just go around and around, things like that. It describes that type of movement. And the context will be different for each one, so we just kind of need to read the prompt and kind of piece it apart little by little. So we have a water wheel, a radius 7 feet. It's rotating at a rate of 6 revolutions per minute. The bottom of the wheel goes 1 foot below the surface of the water. You start your stopwatch. 2 seconds later, point P on the rim of the wheel is at its greatest height. And that last part, assume that D varies sinusoidally with T. They're really just giving us variables to use. We need to use D for distance and T for time, and they're telling us that, it's a sinusoid, a sine or a cosine. So the first thing that we want to do is we actually want to draw the graph. We're going to draw the graph from the context that we have, and then we're going to write an equation from it. All right, so let's, draw the graph. Okay, I'm going to work on the y-axis first, just because I think y-axis is easier. So let's see what clues we have. And these are like little clues in here you're going to have to hunt for. You're going to have to find what it is talking about. So it says the bottom of the wheel goes 1 foot below the surface of the water. So we are going to have a -1 here. So that would be, I'm using the x-axis as the surface of the water. So 1 foot below. Let's see, the water wheel has a radius of 7 feet. So that means its height is 14 feet, right? So if it's 1 foot below, then we know we would, count 14 up. And that would put the very top of the water wheel at 13. Okay, so we have our high and our low value. Now we know working with sine and cosine we need a middle value. So let's see. So that was 14. So half of 14 is 7. So our middle value would be here at 6. Okay, and those are our y values. I'm going to label this axis as D. I encourage you to start labeling your axes. Do you have to? Am I going to count off points? No, I'm not going to count off points, but it's kind of important as we get further on into math. When you get into three-dimensional graphing, you have to label the axes because there's a couple of different ways that the axes could be, shown. So you really have to label your axes once you get there. So this is an option for us. I think we should just practice, just practice to label the axes. All right, so now let's take a look at time. All right, so it says we're doing 6 revolutions per minute. Well, we really want 1 cycle, right? We don't want 6 cycles. 6 revolutions would be 6 cycles. So let's kind of work with that. So instead of per minute, I'm going to use seconds because, again, we don't want 6 cycles. So if it's 6 revolutions per 60 seconds, all right, so let's kind of pare that down. We want 1. So it would be 1 revolution per 10 seconds. Right? 1 revolution per 10 seconds. So what that tells us is that our cycle is 10 seconds. Okay, our period. The period is 10 seconds. Now I want to caution you right here. Earlier people were just starting to label their axes right away. That's really not what we want to do. It's not a general, oh, it's 10, it's 10. They give us another piece of information so that we know how they want us to align the graph. Okay, so there's more information. You don't just find the period and say, oh, it's 0 to 10, we're done. So let's look and see what they're telling us when we have to start. They're saying that, okay, we start the stopwatch. 2 seconds later, point P on the rim is at its greatest height. So what that means is we need to write down 2 seconds and have the point be at the greatest height. Right? That's where we need to start. We don't start at 0. We start at 2 seconds, and that's where we have a high. So I want to pause here for a second. So that is the clue that we are given on how to start. We don't necessarily start at 0. In fact, many times probably most of the time we don't start at 0. Okay, so is everybody okay? So they started their stopwatch, 0 is when they started it, but we don't know where they were height-wise or distance-wise until we get to 2 seconds. So we're going to start there. Okay, so we start at 2 seconds. Now I know that the period is 10, so I'm going to be able to, come out here. I know that goes to 12, right? Where basically the period is 10. Then I'm going to half that, right? A half of 10 is 5. So I would add 5 to 2 and get 7. And then half of 5, right, is 2.5 or 2.5. So now I'm going to fill out my 5. I still need my 5, locations, my 5 on the bottom here. So we have what? 4.5 and then 9.5. Okay, so I have my y-axis done. I have my x-axis done. I'm going to label my x-axis as t because that's the variable that we're going to be using. Okay, now that I have that laid out, I can finish the graph. I'm starting at a maximum, so I'm really going to draw a cosine graph. That would be the easiest one for me to do since I'm being forced to start at a maximum. So I would, put my points here like we typically do. And then I would draw my graph. Okay. Okay, so there is our graph. Now that graph looks like a cosine, so I'm going to use cosine to write my equation. Do I have to use cosine to write my equation? No. We learned, yesterday we can write it pretty much any way we want, depending on our shift. But really, to be honest, why shift? It already looks like a cosine. Let's just write it as a cosine. So let's gather the information that we need to be able to write this as a cosine. So first of all, our A is, our distance, right, between the middle. So this is the middles, and the top are the middles and the bottom. And so, that would be a 7, right? Our A is a 7. So again, we're going to gather information. A is 7. B, if you recall, we find by using the period. Right? B equals, so our period is 10. We know our formula is the period equals 2 pi over B. Right? That's our formula that we have memorized. And so we're going to put a 10 in for the P and solve for B. Okay? And our B value is pi over 5. So I have A and I have B. C. So if you look at that, we've had a phase shift, right? Our phase shift right here, cosine is supposed to start on the y-axis, but cosine is starting right 2. See that? So our C value would be right 2. Okay, which we know when we write it's going to be minus 2, right? That's our C value. Our D value, this was confusing some people earlier. The D value is not -1, right? What is the item of the graph that's on the x-axis is the middles, right? It's the middles, so it would be 6. It would be plus 6. I'm recording a lesson. Okay, so D is going to be like the 6, right? It's in the middle. It's at 6. So D is at 6. Okay, so we have our A, our B, our C, and a D. Now that we have those, we can actually write the graph, right? We can write the equation. So let's do that. So we actually have D, because that was our equation. I'm going to write it in function notation. You don't have to. So D of t, we have that. And so D of t equals, we know it would be our A, which is 7, and then it's cosine of pi over 5 is our B, times t minus 2 plus 6. Okay, so I have our equation now. So notice we graphed it from the context. We looked at our graph and we wrote the equation. Is everybody okay with that? Okay, so now we're going to use the equation like we did in the last lesson to answer questions. They're going to ask us various questions about, certain things. So let's look and see what the first question is. So predict the height of the point P above the water surface when T is 3. So what are they asking us to do there? Yeah, plug in a 3, right? They're basically asking us to make the T value 3. So, and we'll be using our calculators. If you want to use your calculator, that would be great. If you want to plug that in and use your calculator like we did yesterday. We have been having a little bit of trouble graphing also earlier. So I'm encouraging you to be sure that you can put that equation in properly and get the right answers. I also encourage you to put this part right here in a fraction. Put that in a fraction. Lots of people earlier were not putting it in a fraction and their whole graph was off because they didn't, you have to have a certain number of parentheses. They have to be embedded properly. Otherwise, the graph gets messed up. So this pi over 5, I encourage you to use that. Remember, it's the alpha y equal enter will give us a fraction. So go ahead and input that. And then we're going to predict the height of the point P above the water surface when T is 3 seconds. Okay, so I'll just kind of give you that. So it was 11.663. As you're entering this on your calculator, be sure that that is the number that you get. So I'm going to just show so it will be D of 3 equals 7 cosine pi over 5. 3, that would be 3 minus 2, because we're plugging in a 3. 3 minus 2 plus 6. Okay, so we plug in the 3, and then we get D of 3 is 11.663 feet. Now, as far as work goes, if you're using your calculator, for me, you can write D of 3 equals 11.663. You already have your equation right here, right? D of T equation. Then you can just say D of 3 is that. You do not have to show this middle part right here unless you just want to. Okay? Unless you just want to. So be sure that your calculator's in radians as you input those kinds of things. Okay? So let's look at number 4. It says, determine when point P is first at a height of 2 feet above the water surface. Okay, so let's see, what is that asking us? So determine the point P when it is first. Okay, this is significant. The word first. At a height of 2 feet above the surface of the water. So that's like we did yesterday, right? Where we said 2 equals. Remember that? Where we would put 2 equals 7 cosine pi over 5 T minus 2 plus 6. Right, we would go to our calculator, we would have this part in y1. Remember, we would put a 2 in y2 and then we would intersect them. That's like the technique that we looked at yesterday. So that's what you would do. And since it intersects an infinite number of times, they're going to indicate which one they're looking for. This time they said the first. When is P the first at the height of 2 feet? What if it said second? Well, we would look for the second time, right? It could say anything. What if it said fourth? We would look for the fourth time, just depending on what the prompt says. All right, so this says the first time, and the first time would be at 5.468. So T is 5.468 feet. Oops, no, we're in time. We're in seconds. It would be seconds. So 5.468 seconds is our first time that the point is at 2 feet. Is that okay? Okay. The very last one says find the distance from point P to the water surface when the stopwatch started. Now we didn't go back to where the stopwatch started, right? We started at 2, but now that we have the equation, can't we approximate that? We sure can, right? We can approximate that. So I would just need to substitute a 0 in for T, right? To be able to get the height we were at 0 when the stopwatch started. So d of 0 is going to be 7 cosine pi over 5, 0 minus 2 plus 6. Okay, so the distance at 0 is what we're looking at, d of 0. So d of 0, as we put that in our calculator, is going to be 8.163. And that is in feet. Okay, how are we with this lesson? Hopefully it's not too bad because we really laid the groundwork yesterday and the days previous, right? We know how to put this in our calculator. We know how to read, put equations off of graphs and all that kind of stuff. Okay, any questions? Yes?
Are there any times where you use tangents for applications?
For applications like this, no. Other applications we would use tangent for, but not one of like a sinusoidal. All the ones we're going to be working on are sinusoidal, where they have like ups and downs, highs and lows. So that's going to be a sine or a cosine. And really, to be honest, most often it's cosine. Not that cosine is my favorite, but usually they're going to give you high and low points. And so if they're giving you high and low points, that would lend itself towards a cosine, right? High and low, because it starts at a high and then goes to a low, rather than a sine, which starts in the middle. So I would just say most of the equations are written in cosine form. Okay? Uh-huh.
So do you always start the graph at the highest point?
If it gives you the highest point, but what it's good, so the text is going to be different. So some of them may say it starts at the low point, so then you would have to write a negative cosine. So it kind of just depends on what the words are saying, because it's going to lead you in different directions. But normally you're starting at a high or a low. That's the normal of what you're going to get in the word problems. Uh-huh.
So even if for this problem it gave you, the point where it started when it was the lowest height, you would still use a cosine graph?
I would, because even if it told us that it's at a low at 7, let's say it said that, I would still plot that at 7, and I would still want to do, a cosine graph one of the other ways, because it would be easier for us. If we tried to translate to a sine, then we have to figure, which part, where would that land, and it's easier. It's easier to do cosine. Okay? Anything else? All right.